Hello, my name is Draconicrose and welcome back to another episode of While True Do Learn. So last episode we continue on with our tasks, we saw a few bad things and apparently we have a medics to continue. Which I'm not entirely sure, isn't that one of the side ones? Yes it is. We're not interested in the side ones just yet. We only did this one, right? Predict the presidential elections. Then we bought some stuff on eBay. We're still getting a little income. We can get the random forest. Again, I don't see the point. We don't have enough money for more, and the cat skins are also not yet available for us, at least not the ones that I want. DLL. Here you can create your own custom node. You don't have to use all the inputs and outputs. Unused will be disabled automatically. You can edit values in inputs and outputs. New DLL slots can be bought in eBay. Right, this does the custom libraries that we can make, which we will not be messing with right now. Right now we are just going to continue with what the base game has for us. So genetic algorithm training. Good morning. Our center helps in the extraction of data from social surveys. We are facing issues and almost reached our deadline. Please write a program that can extract as many information as fast as possible. Please write something self-learning. Deep news every day since 1905. World Champion versus Genetic Algorithm. One of the greatest chess games of all time is, without a doubt, the battle between Garry Kasparov and the Deep Blue supercomputer by IBM I 1997. The first game was very difficult and tense. Kasparov had an advantage at first, but starting from move 44, many believed that he ceased to understand the logic of the computer and, in the end, lost the entire match. So we've already seen this task before, but in the previous updates. So now what we are going to learn is, machine learning. So in the game, train model in test run until the evolve button does not light up. Then click on it. It creates clone with modified error, positive or negative. In the real world, one of the most powerful self-learning non-neural algorithms, it simulates biological evolution, process, proliferation, mutation, and extinction, only solutions which close to optimum survive. The English on this really needs to be worked on. The duplicator. This node creates several copies of the element. One of the steps in genetic algorithm creates clones of a given object. It helps train the algorithm faster. So let's use both of those and try and create more genetic solvers with better training. And let's do them all sending things where they should go. There we go, pretty simple. This is, the first learning for the genetics and training ones. So we can see here that the genetic solvers did not go well. So we evolve the solver, delete this one. Actually going to give more space between them so that I can more easily evolve them. Yep, there we go. Trying again. And there we go. Awesome sauce. Alright, so I think I understand how we're supposed to use this. We have these genetic solvers, right? So we are going to copy one, the one with the least error rate, and we are going to send, oh dear, we have multiple places for the outputs to go. That's weird. And let's see how that goes. How do the error rates? Okay, then I get it now. What this will do is get all of these inputs and send them all to the genetic solvers. And let's evolve that one. And paste, paste, paste. Give them the things again. There we go, they are at about 23. The run has been completed and 23% error. So I think what this node does is that it grabs all of the inputs from here and sends the exact same amount of inputs for each of the exits. So we get 30 inputs from here, 30 go down off here, 30 go here, and 30 go there. All right, release that one then. Off we go. And the next one, chessbot for training Gasparov. Hi, as you may know, Gasparov will compete with a computer in chess next month. Can you write a chessbot for training? So again, we actually want to. We have a two parallel. That's okay. We want to train these two genetic solvers and have them send one red goes here, one green goes there, blue goes there, one red goes here, green goes there, and blue there. And let's train. Yep, there we go. But the test run is already completed. However, why are the error rates so high? That I don't understand. Let's try that again. The error rate is going down, but it works because of the accuracy. Well, I'll release it. I mean, might be more worthwhile trying to get a more accurate and less error-prone one, but eh. Prediction of earnings in the casino. Hey, hello there. I'm a big gambler. I plan to travel to I think they mean to LA next week and make some money. Did I say some? Well, big money for sure. I need you to write some code or whatever you do there and predict all the ways to win in roulette. If you do everything right, 5% of the bank is yours. Can you handle it? Data of the wins in the roulette is in the attachment. So, again, our idea will be to only get... What did this one do again? Oh, right, it's our genetic divide, which it just did, so not really interesting, and we can't use our red only. So, I guess what we're going to do is get a for parallel going out and grab a few genetic solvers. And send 2 of them to one, 2 of them to the other, trash everything else. And here we go, here we go. Go. Do your thing. Which is not gonna be enough because the errors. What the? 8 and 15? Yeah, because it's because of the errors. Alright, so we'll grab this evolved one and select all of these, delete them, copy, paste, paste, paste. Yep. Then again, what we could do to make this easier on ourselves is, oh dear. What did I... Something weird happened there. We'll... I was thinking, and I know I've just reset its error rate, but that's okay. To do that, then parallelize. Wish there was a way to get all of the outputs and just send them somewhere. Actually not those, I don't want to parallelize those. I only want to parallelize the reds so that they can go there. And for some reason I can't evolve this one. That's weird. Oh, okay, I get it. Because it wasn't actually... Yeah, never do you mind. Well, there we go, evolve, delete, and train again. And evolve, and delete, and train again. Getting better, but not really too good. There's still so much error. Yeah. I think 25, no, we can actually get it even lower than 25% error rate. That is great. So let's do one more, see if we can get the error rate as low as possible. And yes, we can already see that the lowest error rate we're going to get is 9%, so let's release that. There we go. And a UFO recognition system. Hey, please help me. Aliens want to kidnap me. I'm building a large station to watch the sky around my house, but the image recognition system does not work. I know that all the Martian UFO are round, and the Venus battleships are triangular. Please divide them into 2 classes. I must be prepared. I think he got kidnapped. In-game, decision tree, shape. This node compares socket shapes with element shapes and chooses the socket with minimum amount of errors. In the real world, the decision tree can use more complex dependencies. For example, each question may be a sift node, which is trying to find an eye, mouth, tail, or wheel. In summary, decision tree may detect a human, mouse, or car on an image. Very good. Again, an easy one that we can use to, that's actually the other way around, that we can use to finish off the episode. That should be quite enough, so let's go. Pop, 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 pop. Done. And that's a lot of money. Okay, so now as usual, oh, we are making even more income. The overload is still 0. So as usual, we are going to check private emails. No, we have insurance companies that we'll deal with later. But we have new hardware to buy. Woohoo! So now we have stuff for DLL slot, which... But we can get the Rentium 3, which, yes. And can get that. And that. And finally that. And now we are a bit more limited. Yeah. Now we need to earn more money before we can upgrade even more. But that'll be it for this episode. Leave me a thumbs up if you liked it, leave a comment telling me what I could do better or what you thought of the episode, and remember, here there be dragons. Thank you so much to my patrons for making this channel possible. Click the Patreon logo to become one of these fine folk, and if you enjoyed the video, here are some more YouTube things you would like. Don't forget to like this video and subscribe. Have a lovely day, and I'll see you next time.